November 2, 1944. Rechlin Air Base, Mecklenburg, northern Germany. Morning fog rises from Lake Müritz as convoy of covered trucks arrives under Gestapo escort. Inside the main hangar, Luftwaffe engineers have assembled, summoned without explanation, cleared for secrets they do not yet know exist. Oberst Friedrich Weber stands at attention as guards unlock the hangar doors. What rolls into the cavernous space defies immediate comprehension. Boeing B-29 Superfortress, 4 massive radial engines. Silver aluminum skin stretched over frame larger than any German bomber. This is not wreckage salvaged from crash site. This is intact aircraft, force-landed in Siberia by American crew, interned by Soviets, traded to Germany in exchange for jet engine technology under secret protocols between unlikely partners. Weber approaches slowly, his engineer's mind racing through impossible questions. This machine represents leap-forward Germany believed itself leading. Its dimensions mock the He-177, the Do-217, every heavy bomber in Luftwaffe inventory. He has designed aircraft for 22 years, served under Willy Messerschmitt, worked on the Condor and the Heinkel. He believed German aviation unmatched. Now he confronts aluminum evidence that belief was comfort, not truth. The examination begins with Germanic precision. 47 engineers, 9 aerodynamics specialists, 15 metallurgists, 12 propulsion experts, 6 electronics technicians. They work in 8-hour rotating shifts, documenting every system, every component, every design decision embedded in this flying fortress. The numbers accumulate like evidence in prosecution. Wingspan 141 feet, 20 feet wider than any German bomber. Maximum takeoff weight 135,000 pounds, nearly double the He-177. Range 3,250 miles with full bomb load. German bombers struggle past 2,500. Operational ceiling 31,950 feet. Altitude where Luftwaffe fighters cannot effectively intercept. These specifications violate everything Weber understood about strategic bombing doctrine, everything technical journals claimed about structural weight limits, everything propaganda assured about American industrial crudeness. The power plants astound them most. 4 Wright R-3350 duplex Cyclone engines, 18 cylinders each, arranged in twin-row radial configuration. Each engine generates 2,200 horsepower. The engineering represents sophistication Germany cannot match. Dual superchargers maintaining power at extreme altitude, complex cowling designs, managing airflow and cooling, reduction gearboxes translating 2,800 RPM engine speed to optimal propeller rotation. German engines like the BMW 801 or Jumo 211 produce adequate power at lower altitudes, but suffocate above 20,000 feet. The supercharger technology alone demonstrates metallurgical and thermodynamic mastery Germany attempted, but never perfected. Hauptmann Klaus Dietrich, chief of aerodynamics section, spends 72 hours studying the wing design. He photographs, measures, creates detailed technical drawings. The wing incorporates high aspect ratio planform with complex flap system spanning entire trailing edge. But something else captures his attention. Subtle thickness variations along the span, carefully contoured surfaces, leading edge modifications that suggest knowledge beyond conventional airfoil theory. He orders wind tunnel model fabricated at exact scale, conducts flow visualization tests. The results reveal extraordinary aerodynamic efficiency. The wing generates lift, with minimal induced drag across wide speed range. This single innovation explains how the B-29 carries 15 tons of bombs across Pacific distances German bombers cannot imagine. But comprehending and replicating diverge like roads traveling opposite directions. Germany's aluminum supply collapsed 6 months ago. Ruhr Valley refineries bombed into rubble. Bauxite shipments from Hungary severed by Soviet advance. Precision manufacturing equipment destroyed in RAF raids. No replacements possible, no spare parts available. The scientists who might develop equivalent supercharger systems are dead, conscripted, fled to Switzerland. The industrial infrastructure that might build such engines burns nightly under Allied bombing campaigns. They possess the blueprint of transcendence. They lack the foundational capacity to manifest it. December 1944. The reverse engineering project receives official designation from Reichsluftfahrtministerium, America Bomber Advanced Development Program. Reichsmarshal Hermann Göring personally allocates resources with desperation, masked as optimism. Steel quotas diverted from tank production, aluminum scraped from discontinued projects, technical personnel transferred from jet fighter programs. Oberst Weber knows immediate truth his superiors refuse to acknowledge. Germany cannot duplicate the B-29. The industrial capacity, material science, manufacturing precision, all dissolved under 3 years of strategic bombing. But perhaps they can extract principles, adapt core innovations, create German interpretation rather than direct copy. The first compromise cuts deep as surgical incision. The Wright R-3350 engines cannot be replicated. Their complexity demands manufacturing infrastructure Germany lost in 1943. Instead, they must adapt existing Jumo 222 engines, still in development, plagued by cooling problems, producing only 2,500 horsepower combined, compared to B-29's 8,800. Engineer Martin Krauss calculates that power deficit will reduce payload capacity by 60%, range by 40%, ceiling by 8,000 feet. Weber approves because alternatives do not exist. They will build bomber that resembles B-29 superficially while lacking its essential capabilities. Corpse wearing giant's clothing. The pressurized cabin proves equally impossible. The B-29's crew compartment maintains sea-level atmospheric conditions at 30,000 feet through sophisticated system of compressors, regulators, and sealed bulkheads. German pressure vessel technology, developed for U-boats operating at depth, cannot translate to aircraft operating at altitude. The materials differ. Stress loads diverge. Sealing requirements demand precision. German factories can no longer achieve. Test pressure chambers rupture during trials. Seals fail. Compressor systems leak. They abandon pressurization entirely, condemning crews to oxygen masks, frostbite, altitude sickness during high-altitude operations. The advanced fire control system, remotely operated gun turrets coordinated through analog computer, represents technology gap Germany cannot bridge. The B-29's central fire control system allows single gunner to control multiple turrets simultaneously, calculating lead angles and deflection automatically. German equivalent requires manual operation, individual aiming, no computational assistance. The Americans incorporated electronics, servo motors, gyroscopic sensors into integrated defensive system. Germany possesses mechanical gunnery, skilled operators, inadequate technical foundation for automation. Major Heinrich Vogel, production liaison from Messerschmitt, delivers devastating assessment in January. Even this severely compromised design cannot enter production before 1947. Raw materials exhausted, factories destroyed, transportation networks shattered, skilled labor conscripted for infantry replacement. They are designing aircraft for nation that may not survive to see blueprints become aluminum. The project continues because stopping requires acknowledging truths more painful than continued motion. The psychological impact spreads through Rechlin, like contagion, without cure. Engineers who dedicated careers to advancing German aviation now confront physical proof that America surpassed them categorically, fundamentally, irreversibly. The B-29's advantages are not incremental. They represent generational leap in strategic capability that renders all previous bomber doctrine obsolete. Hauptmann Dietrich stops sleeping. He spends nights in the hangar, circling the B-29, measuring wing sections repeatedly, searching for error in calculations that refuse to contain errors. His professional identity was built on assumption of German technical supremacy. That foundation now crumbles, revealing void beneath where certainty once stood. Some retreat into denial. Oberst Gustav Richter insists the B-29 specifications are exaggerated, that actual combat performance reveals vulnerabilities, that German fighters will devastate these lumbering giants once they appear over Reich territory. He writes memoranda emphasizing weaknesses: large radar signature, vulnerable fuel tanks, heavyweight reducing maneuverability. These observations contain technical accuracy. They contain zero strategic relevance. The B-29 operates at altitudes where most German fighters cannot reach, carries defensive armament that shreds attackers before they close to effective range, raids from bases beyond Luftwaffe's operational radius. Traditional fighter tactics are obsolete before first interception attempt. Others embrace brutal clarity. Hauptmann Dietrich begins documenting not what they learned from the B-29, but why Germany could never have built it even with complete foreknowledge. His reports read like autopsies of national industrial strategy. Germany's decision to prioritize tactical air support over strategic bombing, building Stukas and Me-109s while neglecting four-engine bomber development. The failure to invest in supercharger technology when peacetime economy might have funded research. The emphasis on smaller, numerous aircraft rather than fewer, truly capable platforms. The refusal to coordinate air strategy with industrial capacity until catastrophic resource shortages made coordination pointless. Each insight cuts deeper than enemy ordnance. Oberst Weber reads these assessments alone in his quarters overlooking the airfield. Through window, he watches Ju-88 bombers taxi for night missions against Soviet positions. Inadequate range, insufficient payload, hopeless disadvantage against defending fighters backed by industrial capacity Germany cannot match. Young crews who believe German engineering still leads the world. He believed it too 18 months ago. The B-29 represents something more devastating than military setback. It reveals the systematic failures of industrial planning, research investment, strategic foresight that made defeat inevitable years before first American bomber appeared in German skies. They did not lose because Americans fought harder. They lost because Americans built smarter, organized better, understood modern warfare's industrial foundations more deeply. January 1945. Prototype construction begins on what engineers designate Ju-390B, nominal successor to aborted Ju-390 ultra-long-range bomber, now incorporating B-29 principles within German technical constraints. The aircraft takes shape in underground factory near Nordhausen, where slave labor assembles components under SS supervision. Test pilot Major Erich Hartmann examines the emerging fuselage with mixture of admiration and despair. He has flown captured Allied aircraft, Lancasters, B-17s, even a B-24 obtained through neutral channels. If this machine closes even quarter of the performance gap with B-29, it might give Germany strategic bombing capability to strike Soviet industrial centers beyond Urals. First engine tests reveal immediate problems. The Jumo 222 engines, promised for 18 months, remain unreliable. Cooling systems fail after 20 minutes operation. Crankshafts crack under sustained load. Fuel consumption exceeds calculations by 30%. Engineers implement modifications, adjustments, desperate improvisations. Each fix creates new problems. The engines are fundamentally flawed, designed during resource abundance, manufactured during collapse, tested under conditions that would have revealed design flaws if testing infrastructure still existed. They persist because alternative engines do not exist. Hartmann takes the prototype for taxi tests in February. The aircraft handles sluggishly, responding slowly to control inputs. The weight distribution feels wrong. Too much mass forward, insufficient lift from wings sized for more powerful engines. He advances throttles for short hop. Wheels leave ground momentarily before slamming back to concrete. Maximum speed during taxi tests, 180 miles per hour. The B-29 cruises at 230. This aircraft, even if perfected, will be slower, lower flying, shorter range than the American bomber it attempts to match. The handling characteristics reveal deeper design philosophy conflict. The Ju-390B maneuvers adequately for aircraft its size. German designers prioritized handling ease, pilot comfort, systems redundancy. But modern strategic bombing is not about aircraft handling. It is about payload capacity, operational altitude, defensive systems, range exceeding enemy interceptor capability. The prototype excels at irrelevant virtues, while failing at war-winning necessities. Hartmann files report with stark honesty. The Ju-390B represents maximum achievement German industry can currently produce. It is also inadequate for any strategic mission against defended targets. We have built impressive machine for war that no longer exists. Oberst Weber reads this, feels familiar hollowness. They achieved their goal, created flyable bomber incorporating B-29 concepts within German industrial reality, and it changes nothing. The margin of inferiority is not gap to be bridged through engineering cleverness. It is categorical difference in industrial foundation that no amount of technical skill can overcome. Behind the technical project, parallel intelligence operation unfolds. The Abwehr, military intelligence, assigns special section to investigating how America achieved such aeronautical dominance. Oberst Alexander Koch leads team analyzing captured documents, interrogating prisoners, reconstructing organizational infrastructure behind B-29's creation. What they discover proves more disturbing than any performance specification. The B-29 emerged not from individual genius, but from coordinated industrial scientific mobilization unprecedented in history. Boeing designed airframe with input from NACA wind tunnel research. Wright Aeronautical developed engines with metallurgical support from university laboratories. General Electric created remote turret systems. Honeywell produced analog fire control computers. Dozens of subcontractors manufactured components to specifications coordinated through centralized planning. Entire American industrial academic complex functioned as unified organism, directed toward clearly defined objective. Strategic bomber capable of reaching Japan from Pacific Island bases. German aircraft development followed opposite trajectory. Luftwaffe specifications changed monthly based on shifting tactical priorities. Manufacturers competed for contracts, guarded proprietary designs jealously, refused to share research data. Universities operated independently, pursuing academic interests disconnected from military requirements. No central coordinating authority, no shared technical databases, no systematic requirements planning. Individual brilliance achieved remarkable results. The Me-262 jet, the V-2 rocket. But isolated brilliance cannot compete against institutionalized excellence operating at national scale. Koch's reports document structural failures technology cannot repair. Germany's technical education emphasized theoretical purity over practical application. Engineering students learned classical mechanics, while Americans pioneered systems integration, production engineering, operations research. Research funding concentrated on wonder weapons, rather than incremental improvements to existing platforms. The intellectual ecosystem from which B-29 grew simply did not exist in Germany, and cannot be cultivated during wartime collapse. The analysis extends to industrial organization. American aircraft factories operate with assembly line precision, interchangeable parts manufactured to thousandth-inch tolerances, statistical quality control identifying defects before they compound, workers trained to high proficiency in specialized tasks, engineers freed to focus on design while production engineers handle manufacturing, supply chains coordinated nationally through centralized allocation systems. German factories rely on craft production, skilled workers hand-fitting components, constant improvisation compensating for parts shortages, engineers perpetually troubleshooting instead of advancing designs. Koch's final report arrives at devastating conclusion. Germany could not have built B-29 superfortress even if given complete blueprints in 1939, with 5 years to prepare. The aircraft is not merely technical achievement, but product of economic system, industrial philosophy, organizational methodology, scientific infrastructure Germany fundamentally lacked. Copying the machine without copying the civilization that produced it is like transplanting heart without circulatory system. The failure is categorical, irreversible within any time frame relevant to war's conclusion. February 1945. The moral weight becomes unbearable. Oberst Weber sits in meetings with Luftwaffe commanders demanding production schedules, deployment timelines, assurances that new bombers will strike Soviet factories, disrupt American supply lines, demonstrate German technological resilience. He provides optimistic projections while knowing they mean nothing. The Ju-390B will complete flight testing by April, perhaps 12 aircraft produced before war's end. They will fly admirably within their limitations. They will not change strategic balance. They will not prevent Soviet tanks from reaching Berlin. They will not stop American bombers from reducing German cities to ash. The ethical dimension torments him nightly. Every crew assigned to Ju-390B will believe German engineering finally matched American capability. They will trust their aircraft, fly missions with confidence born from propaganda about superior technology, and they will die, not from lack of courage but from mathematical inevitability. He is sending men into combat with equipment categorically inferior to enemies, while telling them they possess competitive advantage. Is this duty or murder dressed in military necessity? Hauptmann Dietrich confronts this moral dilemma through direct action. He requests permission to brief combat crews honestly about performance gaps, to train them in survival tactics rather than victory tactics. His proposal is rejected within hours. Oberst Richter writes scathing response. Such defeatist briefings destroy morale, undermine combat effectiveness, constitute psychological surrender before battle begins. Dietrich responds with survival statistics. Crews who understand aircraft limitations versus those who believe propaganda. His logic is mathematically irrefutable. His report is classified, filed, forgotten. Major Hartman stops writing honest flight test reports. His January assessments praised handling while noting performance deficiencies. His February reports emphasize strengths while minimizing weaknesses. His March reports describe the Ju-390B as fully adequate for strategic missions. He has not changed his professional judgment. He has concluded that truth serves no purpose when reality cannot be altered. Better that crews believe their aircraft competitive than fly knowing doom is certain. The lie seems kinder than truth. He tells himself this while watching young pilots, boys barely 20, some younger, walk confidently toward aircraft that will become their tombs. Weber watches this moral decay with clarity he cannot articulate publicly. They have become complicit in a system that values institutional morale over individual survival, comfortable fiction over devastating reality, short-term psychological necessity over long-term strategic honesty. The B-29 taught them about aerodynamics and industrial capacity, but it also revealed how institutions preserve themselves through managed delusion, how hierarchies demand conformity to comfortable narratives regardless of empirical evidence. March 1945. American and British bombers execute Operation Clarion, coordinated attacks on German transportation infrastructure, rail yards, bridges, canals, highways. The skeletal system connecting German industry to fighting forces disintegrates under precision bombing. The strategic sophistication mirrors B-29's design philosophy, comprehensive systems destruction, rather than isolated tactical strikes. The Allies do not merely drop bombs, they execute campaigns targeting specific industrial nodes to create cascading failures throughout German war economy. The Ju-390B program illustrates cascading collapse with cruel precision. April production schedule calls for 8 aircraft. Actual output, 2 incomplete fuselages. Why? Aluminum shortage because Ruhr refineries destroyed. No replacement capacity exists. Ball bearings unavailable because Schweinfurt factories bombed. No production alternatives. Hydraulic systems delayed because rubber seals unavailable. Synthetic rubber plants in eastern Germany overrun by Soviets. Engine delivery sporadic because Junker's factory in Dessau lacks electric power. Coal supplies exhausted. Transportation paralyzed. Oberst Weber reviews production reports with mounting horror. They are not losing ability to build Ju-390Bs. They are losing ability to manufacture anything. The industrial infrastructure that sustained German military power is being systematically dismantled from above, while resource exhaustion undermines from below. The B-29 sitting in Rechlin hangar becomes sardonic monument. They finally understand its secrets precisely when capacity to apply knowledge evaporates completely. The Allied strategy reveals planning depth Germany never matched. Every bombing raid is coordinated with ground operations, naval movements, intelligence assessments. Air superiority enables all other military operations. Ground forces advance under umbrella of complete aerial dominance. Supply lines operate without aerial harassment. The B-29 in Pacific Theater is not merely weapon, it is key unlocking combined arms warfare at scale. Germany cannot contest with any available resources. Captured Allied planning documents, obtained through Swedish intelligence channels, reveal Americans' understood relationship between industrial capacity and military effectiveness before war began. Pre-war planning calculated production requirements, resource allocations, logistical frameworks necessary for sustained multi-year global conflict. German planning assumed quick victory, favorable settlement before Allied industrial advantages manifested. Both sides assessed American material superiority accurately. One side built strategy accepting that reality. Other side hoped it would not matter, built plans on wishful thinking rather than operational mathematics. Hope was not strategy. Optimism was not logistics. Belief in technological superiority did not create actual superiority. And now payment comes due, extracted in aluminum and blood, in factories burning and pilots dying, in dreams of parity drowning under weight of industrial reality too massive to deny, too comprehensive to overcome, too permanent to outlast. The B-29 represents not just better bomber but better civilization at war, more systematically organized, more rationally planned, more capable of sustaining industrial production under combat conditions. April 1945. The 2 completed Ju-390B aircraft reach operational status. Crews report favorably on cockpit layout. instrument readability, control responsiveness. These positive assessments sound like eulogies praising deceased's virtues while avoiding mention of death. Major Hartmann flies combat sortie against Soviet rail junction near Lodz. Mission succeeds tactically. Bombs strike target. Aircraft returns undamaged. Strategic impact is nil. For every rail junction he destroys, Soviets repair 3 others. German bombing capacity cannot overcome Soviet logistical resilience backed by American Lend-Lease materiel. The mathematics are brutal and simple. America produced 96,318 aircraft in 1944. Germany produced 39,807. American aircraft are qualitatively superior, faster, better armed, longer ranged. Even if German pilots achieved parity in skill, which they do not after years of attrition, numerical disparity guarantees defeat. Add qualitative inferiority to quantitative disadvantage, and outcome becomes not uncertain, but predetermined with mathematical certainty. Oberst Weber knows this. His superiors know this. Yet institutional theater continues. Production meetings discussing delivery schedules that cannot be met. Training programs preparing pilots for aircraft that will not exist. Tactical briefings planning operations with no strategic purpose. Everyone performs roles in drama whose ending was written before curtain rose. The performance continues because stopping requires acknowledging truths more psychologically devastating than continued motion. Hauptmann Dietrich abandons technical work entirely. He spends days in the hangar beneath the B-29, filling notebooks with philosophical observations about technological competition between nations. Americans did not win through superior courage, he writes. They won through superior systems thinking, recognizing that modern warfare is industrial production contest, mediated through equipment performance. They built not just better aircraft, but better factories, better research institutions, better coordination mechanisms between industry and military. We focused on individual technical excellence while they focused on integrated systems. We are craftsmen facing assembly lines, and artisanal quality provides no advantage against mass production efficiency. His commander reads these philosophical reflections, files them without comment. What response exists? Dietrich is correct. His correctness changes nothing. The war grinds forward regardless of intellectual clarity about outcome. Men die daily. Cities burn nightly. Institutional machinery continues because stopping requires confronting truths more painful than motion toward inevitable defeat. They studied the B-29. They learned its secrets. They discovered those secrets arrived too late, revealed too much, demanded more than their civilization could provide under conditions of total war approaching terminal phase. Knowledge without capacity is burden, not advantage. May 1945. Strategic situation deteriorates beyond any possibility of reversal. Soviet forces encircle Berlin. American and British forces advance from west. Germany's territory shrinks daily. The Ju-390B program continues through bureaucratic momentum outweighing strategic logic. Engineers design improvements that will never be manufactured. Production quotas are set that cannot be met. Deployment plans are drafted for aircraft that will not exist. Weber receives orders to brief Luftwaffe High Command on heavy bomber development progress. He prepares presentation emphasizing technical achievements while carefully avoiding strategic assessments. The briefing is theater. Everyone present knows truth, but speaking it aloud violates protocol. He describes specifications, production timelines, potential capabilities. The officers nod, ask procedural questions, express confidence. No one mentions the B-29. No one asks whether new bombers can actually alter war's trajectory. After briefing, senior Luftwaffe general takes Weber aside, speaks with unexpected candor. We are not asking you to win war with bombers. We are asking you to maintain appearance of continued resistance, while political negotiations explore settlement terms. Your aircraft need not achieve victory. They need only demonstrate that Germany retains technical capability, fighting spirit, industrial resilience. This is psychological warfare aimed at occupation terms, not tactical warfare aimed at battlefield outcomes. This honesty, delivered in whisper between official proceedings, contains more truth than 1,000 operational reports. The war's military outcome is determined. What remains is managing perception, preserving dignity in comprehensive defeat, creating conditions for negotiated surrender rather than unconditional obliteration of German state. Weber returns to Rechlin carrying knowledge like physical weight. His engineers work desperate hours designing refinements to aircraft serving symbolic purposes. Test pilots risk death evaluating performance characteristics that no longer matter strategically. Factory workers labor under constant threat producing machines whose deployment will not alter anything significant. And he must maintain their motivation, their belief that effort matters, their commitment to mission whose success is measured in political optics rather than military outcomes. The B-29 still occupies Hangar 3, mostly ignored now. Initially it was mystery to solve, challenge to overcome, enemy to comprehend. Now it is artifact, memorial, evidence of chasm between aspiration and capability, between what Germany imagined itself to be and what it actually was. Young engineers occasionally examine it, less frequently as weeks progress. What remains to learn? They know why it flies higher, ranges farther, bombs more accurately. They know why they cannot replicate it. Knowledge without power to act is burden heavier than ignorance. May 7, 1945. Germany surrenders unconditionally. The war in Europe ends. The Ju-390B program terminates mid-assembly. Aircraft frameworks abandoned in factories. Engines removed for potential use elsewhere. Technical documents hastily buried or burned to prevent Allied capture. The 2 completed aircraft are destroyed by their own crews to prevent capture. Rechlin Air Base prepares for Soviet occupation. Equipment dismantled, research papers scattered, evidence of desperate final months erased as thoroughly as possible. Major Hartmann sits in cockpit of one Ju-390B before its destruction, memorizing control layout one final time. He thinks about the B-29 they studied, about American engineers who designed it. Those engineers never faced combat, never felt aircraft shudder under anti-aircraft fire, never watched comrades burn alive in falling bombers. Yet they contributed more to victory than any pilot's valor. They understood that modern warfare is industrial production contest, mediated through equipment performance at scale. The side that builds better tools in greater quantities wins, regardless of warrior courage animating inferior weapons. This realization does not diminish soldiers' sacrifice. It reveals that sacrifice, however noble, cannot overcome categorical material disadvantage sustained over years. Courage matters, but not more than aluminum production capacity. Skill matters, but not more than manufacturing precision. Will matters, but not more than systematic industrial organization. Germany brought tactical excellence to strategic war, individual brilliance to industrial competition, craft tradition to mass production conflict. Hauptmann Dietrich has already fled west to surrender to Americans rather than Soviets. His final memo, left on Weber's desk, explores philosophical implications of technological defeat. "We confused weapon with hand that made it," he wrote. "We thought understanding the B-29 meant we could build equivalent, but building such aircraft requires industrial ecosystem, research infrastructure, organizational capacity that cannot be improvised during wartime. The B-29 was endpoint of process we never began. We tried to leap directly to conclusion without traversing the path." Oberst Weber reads this alone in empty office as Soviet artillery rumbles in distance. He burns documents methodically, watching years of work transform to ash. The B-29 taught them about aerodynamics, propulsion, systems integration, but deeper lesson was about industrial power, organizational methodology, systemic thinking they understood too late. Not just what to build, but how to build it, how to organize industry, coordinate research, plan production, sustain effort over years. They learned lesson perfectly. The teacher was enemy. The tuition was national destruction. And the knowledge arrived precisely when application became impossible. The Americans arrive at Rechlin on May 10th, 3 days after surrender. Captain James Morrison, U.S. Army Air Force's Technical Intelligence, leads team securing aeronautical research facilities. They find the B-29 where Germans left it, partially disassembled, components spread across hangar floor, measurement marks still visible on wing surfaces. Morrison examines the aircraft with professional interest. The Germans were thorough. Every panel measured, every system documented, every component cataloged. They understood the machine completely. German engineers, now prisoners awaiting processing, provide detailed briefings on their reverse engineering efforts. Oberst Weber explains Ju-390B program with clinical precision, what they attempted, what they achieved, what proved impossible. Captain Morrison listens, takes notes, asks technical questions. The conversation is collegial, almost friendly. These are engineers speaking common language of aerodynamics and propulsion, temporarily unburdened by war's political passions. You understood the design, Morrison observes, reviewing German documentation. The wing analysis is excellent. The propulsion assessment is accurate. Why did replication fail? Weber considers his response carefully. We understood the machine. We did not understand the system that created the machine. Your B-29 is not merely aircraft. It is product of industrial organization we do not possess, research infrastructure we did not build, manufacturing capability we could not sustain under wartime conditions. We could copy design. We could not replicate civilization. Morrison nods slowly. This insight will appear in his intelligence report, not as criticism, but as observation about technological competition's true nature. The Germans were not stupid. They were not lazy. They were trapped in industrial organizational framework inadequate for the war they were fighting. Understanding this distinction matters for post-war planning, for rebuilding Europe, for preventing future conflicts. Hauptmann Dietrich, processed through American POW system, volunteers additional information in exchange for consideration. He provides complete documentation of B-29 analysis. Every measurement, every calculation, every insight gained during months of study. This knowledge should not be lost, he explains. Perhaps someone learns from our failure. Perhaps future engineers avoid our mistakes. The Americans accept this material, file it in growing archives of captured German technology. Some of these engineers will eventually work for U.S. aviation industry, applying knowledge gained from both sides. The B-29 they studied will be shipped to Wright Field for preservation. Historical artifact of war, technological milestone, evidence of industrial scientific mobilization unprecedented in human history. It will sit in museum eventually, silent testimony to the civilization that built it and the civilization that could not match it, despite understanding its secrets completely. August 6, 1945. News reaches American occupation headquarters that atomic bomb destroyed Hiroshima. August 9, Nagasaki follows. August 15, Japan surrenders. The war ends not through graduated attrition but through technology so advanced it renders all previous capabilities obsolete. The atomic bomb is B-29 taken to ultimate conclusion, victory through systematic application of scientific knowledge, industrial capacity, organizational competence that enemies could not match in any domain. Oberst Weber, interned in American POW camp in Bavaria, hears this news from fellow prisoners. He thinks about the B-29 in Rechlin hangar, about the months spent studying it, about the Ju-390B program that consumed resources and achieved nothing strategically significant. They learned everything about how B-29 worked. They learned nothing about how to replicate the civilization that produced it, that could sustain such production through years of global war, that could advance from conventional strategic bombing to atomic warfare within single conflict. The fundamental error was categorical. They treated B-29 as technical problem, copy the wing, replicate the engines, match the performance. But B-29 was not technical problem. It was manifestation of entire industrial scientific system Germany fundamentally lacked. Copying the output without possessing the inputs that created it was impossible. Like attempting to perform surgery after reading medical textbook, you understand procedures intellectually without possessing experiential knowledge, supporting infrastructure, institutional frameworks that make implementation possible. Hauptmann Dietrich, in adjacent barracks, articulates this to fellow prisoners. We confused the weapon with the hand that made it. We thought understanding the bomber meant understanding bombing. But building B-29 required decades of industrial development, research investment, educational infrastructure we never created. The aircraft was endpoint of process we never underwent. We attempted to skip directly to conclusion without following the reasoning that made conclusion possible. Someone asks, what should Germany have done differently? Acknowledged reality earlier. Admitted we could not match American industrial capacity. Built strategy around actual capabilities rather than wished-for parity. Avoided war we could not win. That was political decision, not technical. All technical problems are ultimately political. We failed not because our engineers were inferior but because our political leadership demanded impossible outcomes, and our institutional culture made acknowledging impossibility unacceptable. The B-29 did not defeat us. We defeated ourselves by refusing to see clearly what we faced until seeing clearly no longer mattered. They sit in silence, engineers contemplating civilization's failure embedded in single aircraft's existence. Outside, occupation continues. Inside, understanding arrives too late for anything except informing future. Decades later, historians would analyze Germany's wartime aviation development with perspective unavailable to participants. The captured B-29 superfortress became artifact of broader tragedy, not merely military defeat, but failure of institutions to adapt when reality contradicted ideology. The engineers at Rechlin understood the bomber's technical superiority almost immediately. They reported it through proper channels. Their reports were received, acknowledged, filed, and institutional machinery continued grinding forward, unable or unwilling to incorporate insights demanding too much strategic adjustment. The Ju-390B program eventually gained footnote status in aviation history. Ambitious attempt to match Allied heavy bomber capability too late, with inadequate resources, under impossible conditions. This assessment is accurate and incomplete. It was maximum effort German industry could mount in 1945, and it was insufficient for war Germany was fighting. Excellence within severe constraints remains constrained. The margin between very good and truly exceptional determines outcomes when opponents possess equivalent courage and superior resources. Oberst Weber survived the war, emigrated to Argentina, worked as aeronautical consultant for emerging Latin American aviation industry. He never spoke publicly about B-29 project. Private papers, discovered after his death in 1979, reveal man tormented by clarity he could not act upon. "We understood," he wrote in 1947 journal entry. "Understanding changed nothing. Knowledge without power to implement is burden, not advantage. I knew we were losing while unable to alter trajectory. I understood war was unwinnable while required to act as if victory remained possible. This was not stupidity. It was institutional momentum overpowering individual comprehension." Hauptmann Dietrich became professor of aerospace engineering at Technical University of Munich after release from internment. His lectures included case study on B-29, not as enemy aircraft but as exemplar of integrated systems design, requiring industrial scientific infrastructure, not merely individual technical brilliance. He taught generations of students that technical excellence begins with honest assessment of capabilities, constraints, objectives, that systems must be designed for reality, not aspiration, that understanding opponents' advantages is prerequisite for developing effective responses. The captured B-29 was eventually transferred to Smithsonian Institution, preserved as historical artifact. No photographs survive of German analysis efforts. Documentation destroyed during final days. But lessons remained, encoded in memory of those who studied it, who recognized too late what it represented, who learned that technological competition between nations is won not through individual genius, but through systematic cultivation of knowledge, resources, institutions making genius possible at scale. They arrived as conquerors of sky. They departed as witnesses to what comprehensive industrial power, properly organized and strategically applied, could create, and what it could destroy.